In this video, we just have to find out the classical critical point first of all. Then we will have to find out whether they are local maximum, local minimum, or they are saddle, or they are indefinite point. So given question is there. So first of all, for critical point, for a critical point, first derivative is always equal to 0. That will be a condition for the critical point. And then we'll see what will be the local maximum, local minimum, or saddle point conditions. So first we find out the critical point. We call it f of x y, that is two functions, that is independent variable x and y. So we write it as f into xy, x4 plus x square minus 6xy plus 3y square. First of all, we will have to take a partial derivative with respect to x and y, first derivative. So f of x, that is partial derivative, we can write it partial f over partial x. So that is an f of x. So with respect to x, we can write it 4x cube plus 2x minus 6y with respect to x. Same likely, we will take fy, means partial derivative of y from this equation. So when we take partial derivative, these will be the x4 and x square will be ignored. This will be a 6y minus 6x. Now for critical point, I already says that is f of x equal to 0 and f of y equal to 0. So when f of y equal to 0, 6y minus 6x equal to 0, we can say that is 6 and y minus x equal to 0, y minus x equal to 0. So y becomes equal to an x. Y becomes equal to an x. Similarly, from partial derivative of x, f of x, it becomes also equal to 0. So 4x cube plus 2x minus 6y equal to 0. Now we put the value of y equal to x. 4x cube plus 2x minus 6, and here we put the value of y, that will be an x equal to 0. So x, we take the x will be a common from whole of the equation, and 2x will be a common. So remaining will be 2x square plus 1 minus 3 equal to 0. So now 2x equal to 0, and this will be also equal to 0. 2x square minus 2 equal to 0. So x square will becomes equal to a 1, x will be a plus minus 1, or here x is equal to 0. Now if x is equal to 0, when x is equal to 0, so because x becomes equal to a y, when x is 0, so y also 0. When x is positive 1, then y also positive 1. When x is negative 1, so y will also be a negative 1. So these are the points which are our critical points. Now we have to calculate the local maximum, local minimum, or saddle point. So for all these equations, we have to understand about the Bayesian method. Bayesian principle, that is f of double x, f of xy, f of yx, and f of double y. These are the Bayesian matrix. Or this will be a f of double x. This will be a leading minor. F of double x will be called is a leading minor. leading minor. So there will be a different types of conditions. Now we will have to find for the local maximum, minimum or saddle point. If at any case if the leading minor, that is f double x, f double x means f double x greater than 0, positive, and whole of the Hessian matrix and whole of the determinant, I can say f double x, that is an h1. h1 is greater than 0, and whole of the determinant I say that is h2. h2 greater than 0. If both the conditions are greater than 0, then this will be a positive definite. Positive definite. Positive definite. If h1 means leading entry, leading minor, is greater than 0, but whole of the determinant will be h2, that is a less than 0. Less than 0 but means it will be a negative sign. Negative sign. So it will be a indefinite, that is indefinite. Second condition. And in third case, if h1 is negative, h1 is negative and h2 is positive, then negative definite. Then negative definite. So these are the conditions where we have to look at this. And if both are positive, then local minimum. And if one is negative and other is positive, then local maximum. And if there will be a neither maximum nor minimum, then there will be a saddle point. So these are the conditions which we will have to find out in this question. Now our first derivative is like that. This is the first derivative, f of x, that is 4x cube plus 2x minus 6y. And now we have to take the second derivative with respect to x. So what will be the 4x cube, that is a 12x square plus 2. This will be a second derivative. And same likely we have to find f of y. F of y is that is 6y minus 6x. So f double y with respect to y. Now partial derivative with respect to y. So with respect to y, that is a 6. Now take f of xy which becomes equal to f of yx. Means to say if we take the x first derivative, now from this equation, from first derivative, we take the second derivative with respect to y. Now we will see with the respect of y, so 2x and 4x cube will be 0, so minus 6 will be the answer. Now Hessian matrix will write it as f double x, f xy, f yx and f of double y. F of double x is what? F of double x is this, like that. This is the equation, 12x square plus 2. F of xy, that is minus 6, and minus 6 is here, and f of double y, that is a 6. Now these are our critical points. First of all, minus 1, minus 1. So we take first of all minus 1 and minus 1. 12x square plus 2, we can say, now put the values of this. Minus 1, minus 1 means the value of x is minus 1 and value of y minus 1. So here if we put the value of x minus 1, so this will be a 12 and plus 2, 14, minus 6 and 6. Now we will calculate the value. We take the determinant, 14 into 6 minus 6 into minus 6. So the result will be that is 48. 48 which is greater than 0. Means to say, if we close a look of this question, now look at this. Leading minor entry, what is f of double x? What will be the answer? That is 14. 14 is greater than 0, and whole of the determinant answer is 48, which is greater than also 0. Both of them are greater than 0. So to calculate, we just put the values of -1 and -1, which comes from a critical point. Now we'll take value 1 and 1 and again put the values of this determinant, and we'll see what will be the answer of this question. Now we take the second value, that is 0, 0. So we take the value of 0, 0 again. So when we put the value of 0 from this equation, this will be a 0. So will be remaining 2, -6, -6 and 6. Now we will calculate the value determinant. 12 minus 12, that is a 0. That is the answer as 0. So 0 will represent as a saddle point. This will be a saddle point. So last critical point will be left. Now again we will take this one again, Hessian, that is 12x square plus 2 minus 6 and 6. Now take the last value, that is 1, 1. We put the value of 1, 1, means the value of x will be 1 and y will be 1. So we put the value of, when we put the value of 1, positive 1, again 14, -6 and 6. So answer 14 into 6 minus 6 into -6. So result will be 48, which is greater than 0. So look at this, 14, that is h1, leading minor, greater than 0. 48, whole of the determinant, again greater than 0. So both are 0, greater than 0. So what will be the local minimum? So this will be the question of 17.1. This will be a second question, that is a C part. Again we will first of all we will have to find the critical point. So for this we take the partial derivative of x, f of x. So when we take the partial derivative, then y square 3x square y and minus y. Now take a partial derivative with respect to y. So f of y will become 2xy plus x cube minus x. This will be the first derivative. Now for critical condition point, f first derivative is always equal to a 0. Means to say f of x 0 and f of y also becomes equal to a 0. So y square plus 3x square y minus y equal to 0, and 2xy plus x cube minus x equal to a 0. We take the common y. So y plus 3x square minus 1 equal to 0. So we can say y equal to 0 and y plus 3x square equal to 1. This will be the first condition. Now we'll take the again x common here. So 2y plus x square minus 1 equal to 0. Here x equal to 0 and x square plus 2y equal to 1. That is equal to a second condition. Now look at this. First point we have calculated, that is 0, 0, which is a critical point. I will write it here, critical point, that is first point is 0, 0. Now if we take the value of 0 and put the equation in 1, then y equal to 0, so 0, 1 will be a point. So this will be a second point, 0, 1. When we take the value of y 0 and put the equation in second, y 0, so x square equal to 1, x equal to plus minus 1. So this will be a 0 plus 1 and 0 minus 1. These are the two values have come from. That is 2 further points, 0, 1 and 0 minus 1. oh sorry, x will be write it at first, x will be write it as first. So 1 0 and minus 1 0, here also 1 0 and minus 1 0. Now we have 4 critical points to find out. Now we will solve these two equations. 3x square plus y equal to 1, that is equation 1, that this will be equation 1, and x square plus 2y equal to 1. 3x square equal to 1 minus y, x square equal to 1 minus y upon 3. Now this value will put in here from x square plus 2y equal to 1. Now I will put this value from this equation. So 1 minus y upon 3 plus 2y equal to 1. 1 minus y multiplying by 3, so 6y equal to 3, 5y equal to 2, and y equal to 2 by 5. The value of y will be 2 by 5. Now put this value into this equation. X square 1 minus 2 by 5 and 1 by 3 will be write it as a separate. So this will be a 3 by 5 and 1 by 3. So 1 by 5 x square. So x will be plus minus 1 over root 5. Again two values comes here. 1 over under root 5, 2 by 5, and 1 over under root 5 minus 2 by 5. Minus and 2 by 5. So I have got it the points. 1 over under root 5, 2 by 5, minus 1 over under root 5, and 2 by 5. These are the 6 points which we have got for the critical point. Now from these 6 points, we will find whether local maximum, local minimum, or saddle point. Now for local maximum, minimum, and saddle point, we take the second derivative, f of double x, second derivative with respect to x. So this will be a 0 and this will be a 0. So this will be a 6xy, second derivative. Again f of double y, second derivative with respect to y. With respect to y, both are 0, so this will be a 2x. Now f of xy, which is equal to f of yx. F of yx, y, this will be f of y with respect to x, now with respect to x. Or either you can calculate here from f of x with respect to y. So you can calculate anywhere. I will calculate here from f of yx. F of y by x will be like that of 2y plus 3x square minus 1. Now first of all take the Hessian method. Hessian, that is f of double x, f of xy, f of yx, and f of double y. Now first of all, my first critical point, that is 0 0 0 0, I will on f of double x is what is, that is a 6xy, 6xy. F of xy, this will be a 2y plus 3x square minus 1, or same will be here, 2y plus 3x square minus 1, and f of double y, that is a 2x. At value is 0 0. First critical point is 0 0. Now what will be the answer? 0. When we put x0, y0, they all will be a 0. When we put x0, y0, again both of 0, minus 1 is left there. This will also a minus 1, and this will be a 0. So look at this, the leading minor 0, leading minor is 0, so this will be a saddle point. This will be a saddle point. First critical point at 0 0 will be a saddle point. Now we will take the second derivative, second equation, second saddle point, second critical point, that is 0 1. Now I will write it now here 0 1 0 1. I solve here 0 1. Now again, when you put the value of a saddle point from 0 1, again 0 x 0, so whole of the 0 x 0 y 1, so this will be a 1, x 0 whole of the 0, so 2 minus 1 1, and here 0, so again this will be a 0, so again will be a saddle point at 0 1. This will be a second critical point at 0 0 saddle point. Now at 0 1 also a saddle point. Now the third point is what? Now take 1 0. When we take 1 0, it means that the value of x is 1 and y is 0, so whole of the 0, whole will be 0, and again y 0, and x will be 3 minus 1 2, and same will be here, and 2 is there. So look at this, here is a 0, so no need to further solve, that is a saddle point. I will write it here at 0 0, the answer is a saddle point, at 0 1 also a saddle, and at last 1 0, the result is also a saddle point as a saddle point. Now the fourth value, I will take minus 1 and 0. So again, if we take minus 1 0, it means whole of the value is 0, and no need to further solve it, because when leading minor is 0, so this will be a saddle point. So when we put minus 1 0, it is also a saddle point. Now last 2 points are left there. Now calculate the value of 1 over under root 5 and 2 over 5. Put the value of x 1 over under root 5, and value of y is 2 by 5, and same here 2 by 5 plus 3 x 1 over under root 5, so square will becomes equal to a 1 over 5 minus 1, same will write it here 2 by 5 plus 3 into 1 by 5 minus 1, and from here x 1 over under root 5. So after calculation, all these calculation, I solve it 1.07, 0.4, 0.96, and 0.16. So when we solve this determinant, the answer is 0.8, which is greater than 0. And look at this, the leading minor is also greater than 0, and the whole of the determinant is also 0, so will becomes equal to a local minimum. So 1 over root 5, 2 by 5, that is a local minimum. So last value you can calculate yourselves. This will be the question of critical points.